Imagine this: a sunflower, a seashell, and a galaxy. What could these three possibly have in common? The answer lies in an incredible mathematical principle, the Fibonacci sequence. Why does this sequence seem to pop up everywhere in nature? How does it work? And what does it reveal about the world around us? Stick around as we crack the code of nature itself. Before we get started, if you enjoy uncovering the mysteries of science, math, and nature, don't forget to like this video and subscribe. Your support helps us grow like a Fibonacci spiral. Let's start with the basics. What exactly is the Fibonacci sequence? It's a series of numbers where each number is the sum of the two before it. It starts like this: 0, 1, 1, 2, 3, 5, 8, 13, and so on. Here's a fun way to visualize it. Imagine two rabbits. In the first month, you have one pair. In the second month, they reproduce, and now there are two pairs. By the third month, there are three pairs, then five, and so on. The population grows exactly like Fibonacci numbers. But this sequence isn't just about rabbits, it's about growth, patterns, and how things multiply or expand in the natural world. Now that we know what the Fibonacci sequence is, let's explore where it shows up in nature. One of the most famous examples is the sunflower. If you look closely at the arrangement of its seeds, you'll notice they form spirals that match Fibonacci numbers. The same thing happens in pine cones and pineapples. Count the spirals in one direction, then count the other. The numbers are consecutive Fibonacci numbers. But it's not just plants. The curve of a seashell follows a Fibonacci spiral. Even spiral galaxies in space, massive structures containing billions of stars, often follow the same pattern. It's as if the universe has a hidden blueprint, and Fibonacci is the architect. This brings us to the big question: why does the Fibonacci sequence appear so often in nature? It comes down to efficiency. Nature uses Fibonacci patterns because they're the most efficient way to grow and organize. Take the sunflower. Its seeds grow in spirals to maximize space and ensure that every seed gets sunlight. The Fibonacci sequence allows the plant to pack the most seeds in the smallest area. This principle isn't limited to plants. Animals, cells, and even hurricanes follow similar patterns. It's nature's way of getting the most out of limited resources. The Fibonacci sequence is closely tied to something called the golden ratio. Here's how it works. Divide any Fibonacci number by the one before it, and you'll get a number close to 1.618. That's the golden ratio. This ratio is everywhere. It's found in art, architecture, and even in the design of your smartphone screen. Scientists believe we're hardwired to find this ratio beautiful. It shows up in our perception of faces, landscapes, and even music. It's amazing to think that a simple mathematical sequence not only organizes nature, but also shapes our sense of beauty. You might be wondering, is this just a coincidence? Why does it matter? The truth is, it's not a coincidence. Biologists and mathematicians have studied these patterns for centuries. The Fibonacci sequence is tied to how living things grow. Cells divide, plants compete for sunlight, and galaxies expand, all guided by the same mathematical principles. Understanding these patterns helps us appreciate how interconnected everything is. It's a reminder that the universe isn't random. It's full of purpose and order. The next time you're out in nature or even scrolling social media, take a closer look. You'll start to see these patterns everywhere, in the spirals of flowers, the shapes of seashells, and even the clouds in the sky. Fibonacci's code is all around us, hiding in plain sight. If you found this as fascinating as I do, hit the like button and subscribe to the channel. Share this video with someone who loves discovering the hidden beauty in our world. Because math isn't just numbers, it's the secret language of the universe. And now you speak it. Thanks for watching, and I'll see you in the next video.